Hi, and welcome to College Algebra 6.3 Multivariable Linear Systems. So today we're going to focus on Gaussian elimination. Frankly, it means we're going to use three different variables here. So we often want to eliminate one variable, but you end up eliminating the same variable a second time. So because I'm starting with three variables, I need three equations to start. So by eliminating one variable, I'm going to create a fourth equation, and then by doing that same variable, I'm going to create a fifth equation. But the nice thing is about those two equations is now they're just two equations that have the same variable. What do I mean by that? Well, let's say I have x plus y plus z equals 10, x minus y plus z equals 11, and x minus y plus 2z equals 12. I can see that if I combine these first two equations, my y's will eliminate. So I'd end up with 2x plus 2z equals 21. And I need to pick a different combination of two equations. So I'm going to combine the first and third. Again, my y's would cancel out. So I end up with 2x, no y's, 3z equals 22. And now I've generated what I'm talking about, my equation 5 and my equation 4. Well, now looking at these two equations, I have two equations with the exact same two variables, so I can solve them. So really what it comes down to, if I have a 3 by 3 system, I just want to break it down into a 2 by 2 system and use the exact same methods of solving that we've already been using, whether that be graphing or elimination and substitution. So let's try one. We have x plus y plus z equals 6, 2x minus y plus z equals 3, 3x plus y minus z equals 2. It doesn't matter which variable you can eliminate. I would say that all three are pretty easy here. Probably y and z would be the easiest ones because we have some natural combos. So if I combine these two equations right here, x plus 2x equals 3x, y plus negative y cancels, z plus z gives me 2z, 6 plus 3 gives me 9. I eliminated the y, so I want to find a different combination of two equations that eliminates the same variable. So I can combine these two. 2x plus 3x is 5x. Negative y plus y cancels. Z plus negative z also cancels, and I get 3 plus 2 is 5. Well, here it actually makes things even easier because now this blue equation, I can just solve for x, and I get x equals 1. And just like the last couple days, we're going to start substituting backwards. However, I don't want to put x equals 1 into one of my originals because my originals would still have two variables and I'd kind of get stuck there. So I'm going to plug it into either equation 4 that we generate or equation 5. In this case, obviously, equation 4, because that way, if I plug 1 right there, I can solve for the z term. So when I get 3 times 1 plus 2z equals 9. So I can subtract this 3 from both sides. So I get 2z equals 6. Divide by 2, we get z is 3. Now, I can take z is 3 and x is 1 and plug it into one of my original equations to solve for y. For the sake of argument, I'm going to plug it into the first one. So I would get 1 plus y plus 3 equals 6. 1 plus 3 is 4. So I get y plus 4 equals 6. Minus 4, I get y equals 2. So I would get the thing 1, 2, 3. It's important to note that I have three variables to solve for. So therefore, what I need is what's called an ordered triple. Last couple of days we had ordered pair, which makes sense because we only had two numbers. Here I have three numbers, so I need an ordered triple. Okay, on to the next one. 3x minus 16y minus 2z equals negative 10. X minus 3y plus z equals 4. And 2x plus y minus z equals 6. For this one, I would probably eliminate the z's because I'm seeing some very easy ones. For example, these two combine right here. My z's are going to cancel immediately. So x plus 2x is 3x. Negative 3y plus y is negative 2y. Z's cancel. 4 plus 6 is 10. And if I multiply this equation by 2, I would get 2x minus 6y plus 2z equals 8. And I can actually combine it with the first equation. So 3x minus 16y minus 2z equals negative 10. And I can just combine those. So that would give me 5x minus 22y equals negative 2. From here, I could either multiply the top by 5 and the bottom by negative 3, or vice versa of negative 5 and positive 3, or I could multiply the top by negative 11, which I think I'm going to do that one. So if I times this by negative 11, I get negative 33x positive 22y and negative 110. So I would combine, so I'm going to get negative 28x equals negative 112. So I can do negative 112 divided by negative 28 and get positive 4. I can take that x equals 4 and plug it in for either the red x or the blue x. So 3 times 4 minus 2y equals 10. That's 12, so subtract 12. Negative 2y equals negative 2. Divide by negative 2, divide by negative 2, y equals 1. Plug both those into one of the originals. Looks like the bottom one's probably the easiest. So 2 times 4 plus 1 minus z equals 6. 2 times 4 is 8, plus 1 is 9, minus the 9, minus the 9. We get negative z equals negative 3, divided by negative 1, divided by negative 1, z equals, positive 3. So I would get 4, 1, 3. So if in order to solve a 3 by 3, you have to break it down into a 2 by 2 first, here I have a 4 by 4. I have 4 equations and 4 variables. How do you suppose you would do that? Well, you would take your 4 by 4 and break it down into a 3 by 3 first, and then break it down into a 2 by 2. So the first thing I would look for is a variable that's probably easy to eliminate. Looking at the equations here, I would actually say z is the easiest to eliminate by pure definition that the second equation already doesn't even have a z. So I can already use this equation because it has 3 variables. So I just need to eliminate the z 2 other times. So if I combine equations 3 and 4 here, so that would give me negative 3x plus x is negative 2x. 4y plus 2y is 6y. Z minus z cancels. 2w plus w is 3w. And 4 plus 0 is 4. And I could see that equations 1 and 4 can combine pretty easily. So x plus x is 2x. Y plus 2y is 3y. Z's cancel. W plus w is 2w. Equals 6 plus 0 is 6. And then, again, I could just steal this equation right here because the z's already eliminated. So 2x plus 3y minus w equals 0. So now I have a 3 by 3 system. So all I have to do now is get it down to a 2 by 2 system. Well, I can combine these two equations to eliminate my x's. So that's going to give me 0x, 6y plus 3y, that's 9y, 3w plus 2w, that's 5w, 4 plus 6, that's 10. And then I can combine the first and third equations to eliminate the x's again. Negative 2x plus 2x cancels. 6y plus 3y is 9y. 3w minus w is 2w. 4 plus 0 is 4. From there, I can multiply one of my equations by negative 1 for the sake of argument, this first one. So negative 9y minus 5w equals negative 10, and I can combine those two equations. Y's cancel. I get negative 3w equals negative 6, so therefore w equals 2. From there, I could plug w into one of these equations, solve for y. Then I could take w and y, plug it into these equations up here and solve for x. And then I could take all three in one of these originals and solve for z. So that's kind of the process there. So if I had a 4 by 4, I'd break it down to a 3 by 3. Following that logic, if I had a 5 by 5, I'd break it down to a 4 by 4, and then a 3 by 3, then a 2 by 2. And following that logic, anything bigger, you would just bring it by the scale of 1 less. Thank you for listening, and I hope you have a wonderful day.